It is the 14th of May, and when we last left our Chemistry Heroes, we had just started to dip our toes, metaphorically, into solubility values. This is one of those things that's an ACT score booster, because it's, again, a chart and graph plus additional information that you have. So you're making use of multiple things, and those are the kind of skills that the ACT tests on, largely. So we know that heating, and I asked you that question for a reason, heating increases the amount of solute that you can get to dissolve in a solution. We can actually measure how many grams of any solute can dissolve in a given amount of solution, or in a given amount of solvent. And what you have in front of you, this is an excerpt from a much larger solubility table. Notice that all these compounds start with S. That's because this is just the S page, the S chart. It goes A through Z for a bunch of different compounds. But what it gives you, and if you start on the front is the one that has the temperatures across the top. I didn't realize that row didn't carry to the other side, so it's a little hard to read. You'll have to transfer those. I can take a picture of it. So this is, there's a much smaller table in your book. The one on 404 is much smaller. What we're going to do is practice working with this. So for any given substance, we have here silver nitrate. Okay, that's a good one. So silver nitrate, AgNO3. You've worked with this compound. This was one of the reagents that you used when you did your silver ornament lab. You got the silver to precipitate out of solution. Silver nitrate is soluble in water. Most nitrates are. We'll talk more about general solubilities in the next chapter. If I have, well, first of all, let's establish a few things about this table. Just like the table in your book, this table is per 100 grams of water. Okay? So this is given in grams of solute per 100 grams of water. How many grams of solute can we expect to dissolve in 100 grams of water? So if we look at silver nitrate, the first column on the table, if you look at the heading, if we look at the first column, the first column that has numbers in it, at the top, what's the heading read? 0 Celsius. So that column is telling us how many grams of silver nitrate we can dissolve in 100 grams of water at 0 Celsius. It's going to be the lowest number on your chart. Why isn't there a number lower than 0 Celsius? Yeah, because below 0 Celsius, the water wouldn't be a liquid. It would be something that would be very hard to dissolve stuff in. So, okay. If we have 100 grams of water at 0 Celsius, how many grams of silver nitrate can I dissolve in there? This is just reading the chart. 122 grams of silver nitrate. So, at 0 degrees Celsius, in 100 grams of water, I can dissolve 122 grams of silver nitrate. Good. Is that a unsaturated, saturated, or supersaturated solution? Stick your thumb on your head if you think you know. If I have exactly 122 grams at 0 Celsius and 100 grams of water. Unsaturated, saturated, or supersaturated? That's a saturated solution. It's got as much solute as it can hold. It doesn't have any more, it doesn't have any less. It can't, under those conditions, accept more solute. Okay? What happens if I have a solution, again, of silver chloride, or silver nitrate, sorry, also at 0 degrees Celsius, also in 100 grams of water, and I have 75.2 grams of silver nitrate in there. Is that saturated, unsaturated, or supersaturated? That's unsaturated. That one can dissolve more. It can absorb more. Not absorb. It can dissolve more solute. So here comes the most interesting bit as far as I'm concerned. If I take this solution, the one with what we said was a saturated solution, and I keep it at 0 degrees, but I add 10.0 grams of silver nitrate, what's going to happen? No. What's going to happen? What's it going to look like after I do that? Pardon? Yeah, under those conditions, it will not dissolve that additional 10 grams of silver nitrate. We're going to have chunks, to use the super technical term. There will be chunks. Now, most commonly, to create a supersaturated solution, I need to take this, so I'm going to borrow that, take this solution, heat it up. Let's say I heat it up to 20 degrees Celsius. At that point, is it saturated anymore? No, at 20 it's no longer saturated. It's now an unsaturated solution. If I then add even 15 grams of silver nitrate, and then, this is the critical piece. So if I add 15 grams of silver nitrate to it at 20, is it saturated? You have to look at your table. What are the total number of grams that I've got of solute in there now? Yeah. Yeah, 137. Is it saturated? No. Now if I take that, so here I heated it, and I cool it back to 0 degrees Celsius, and nothing falls out. No chunks precipitate out. What is true of my solution? Now it's supersaturated. Now it's supersaturated. Now, doing that requires a great deal of caution, because the most common thing that you're going to see is if you take this solution, copy, heat it up to 20, add whatever mass of silver nitrate, and then cool it back down to 0, you know what's going to most commonly happen? That additional 15 grams of silver nitrate is going to precipitate right the heck out. It's just going to fall out. Because at 0 degrees, it can't dissolve that much silver nitrate. So very commonly, that additional mass of solute will just precipitate out. Occasionally, you can, if you're real careful, and it involves things like, keeping it agitated, cooling it slowly, all those sorts of things, you can sometimes get it to hold on to that additional solute. That's when you have a supersaturated solution. Liters of water at 40 degrees Celsius is a solution containing 32 grams of sodium chloride saturated. There is something you have to do first here. Your chart is all given to you in what units of solvent? Grams. That's rotten. I didn't give it to you in grams. What did I give it to you in? Milliliters. So what do you have to know? What relates mass and volume? Density. How much mass per unit volume you see? I can't think of any more words. Yeah, you have to know the density of water. What's the density of water? Grams per milliliter. What's the density of water? How many grams per milliliter? You didn't get my musical cue, did you?
What?
My musical cue? One is the loneliest number that da-da-da-da. No. 1. 1 gram per milliliter. So 100 milliliters of water is just 100 grams of water. I started off small on that because I'm going to get... So 100 milliliters of water is just 100 grams of water. What do you think that means I'm going to do to you on quizzes and tests? Given 1 liter of water, given 250 milliliters of water. So we're going to practice some of those too, but you have to, realize that you have to think about the density of water. Okay, so don't freak out when you see something in milliliters and you go, "Bye, I only have it in grams." For water, it's 1 to 1. Okay. Is it saturated? Yes or no? No, it's not saturated. This is an unsaturated solution. Because 100 grams of water at that temperature could dissolve how much sodium chloride? Yeah. It's not saturated. We can actually dissolve 36.37 grams of sodium chloride. So one of the other kinds of questions that I could ask is, can 100 milliliters of water at 42 Celsius containing 32 grams of sodium chloride dissolve 2.5 additional grams of sodium chloride? So, can it dissolve an additional 2.5 grams of sodium chloride? Yeah, it can. Let's practice some that get just slightly trickier. Okay. In 375 milliliters of H2O at 20 degrees Celsius, you have dissolved 133 grams of NaCl. Is the solution saturated? How many of you have a ready answer without doing anything? Okay. Yeah? What do you think? Do you think there's a trick?
Yes.
Okay, you suspect treachery.
Yes.
Wise. Wise.
Because the chart's in 100.
Right.
And that's 675.
Yeah. So this isn't, I'm not playing softball anymore here. I gave you 375 milliliters of water, not 100 milliliters of water. So we have to do, and we can do this as a factor label. That's the easiest way. You're familiar with factor labels. They're nice because they do themselves. So we're going to say that we have 133, well, actually, hold on. We have 375 milliliters of H2O, and we know that for every 100.0 grams of H2O, we can dissolve what? You know what, I'm going to put a little note in here that reminds me of the temperature. We're at 20, right? We can dissolve, actually, let me move this over. We can dissolve 35.89 grams of sodium chloride. We have a problem with this as a factor label. What's the problem? Yeah, so far none of our units match to cancel. We got nothing connected here. Well, let's work towards getting this into grams of water. Okay, so for every 1 milliliter of water, we have 1 gram of water. So that's going to cancel out our milliliters. That's going to cancel out our grams. We're going to cancel out water. What are we going to be left with as an answer? What will our answer mean? First of all, what units in chemical? Grams of sodium chloride. What will that answer mean for us? What is it? Well, what it's actually going to give us, our answer, is going to be the grams of sodium chloride that can be dissolved. Okay? That's what it's actually going to give us, is how many grams of sodium chloride we can dissolve. So, what you got? Oh wait, you don't have calculators. Okay, so if we do our raw numbers here, we get 134.5875 grams of sodium chloride is what this solution could dissolve. So is this saturated? No. Not quite. It's real close. You couldn't put a whole lot more salt into it, but it's not yet saturated. It's not a saturated solution at this point. Okay. So that's one step of complication, giving you more than 100 grams of water. What other steps of complication could we perform? I know. Okay, so we've got 250 milliliters of water at 30 degrees Celsius. We have 93.72 grams of sodium bromate dissolved in it. If we cool that whole solution down to 0, how much precipitate is going to fall out of this? Gesundheit. What's the mass of precipitate we're going to get out? This is a multi-step problem. What's our first step? So one idea on the table here is we start off with a factor label, and we go from the 250 milliliters of water to the number of grams of sodium bromate that can be dissolved in it at 30 degrees Celsius. That's one idea. I think it's fantastic. I just have one problem with it. Well, let's try it. Let's try it. What the heck? Let's see if we can figure out what the problem is. So we would start setting up this factor label with our 250 milliliters of water. And you said we want to do this at the 30-degree solubility. So at 30 degrees, we can dissolve 42.6 grams of sodium bromate, NaBrO3, in every 100.0 grams of water. So we have that, and then we need to do our conversion from milliliters of water, or grams of water to milliliters of water. So we know that every 1 milliliter of water has a mass of 1 gram. And we know that our answer is going to be in what units? Yeah, grams of sodium chloride. So that's all good. Whoops. Before I write anything more, 106.5 grams of sodium chloride. Yeah, helps if I put in the right compound, sodium bromate. Sorry about that. Nah, bro. Do you want sodium bromide? Sodium bromate? Nah, bro. No, okay. What does this tell us? So we have a number, 106.5 grams of sodium bromate. So, is that how much precipitate we're going to get out? What is it?
That's how much we can dissolve in
At 30? What do we want to know? Oh. What do we want to know? We want to know 0 degrees? That's what I hear muttering of.
How much can we dissolve at 0 degrees?
Oh, excellent. We want to know how much this solution can dissolve at 0 degrees. So this was a great idea, but we need to change something. So I'm just going to borrow most of this, and I'm going to get rid of the 30, and I'm going to go for 0, and I'm going to look up the solubility at 0 of sodium bromate. What is it? 24.2 grams of sodium bromate for every 100 grams of water. So 24.2 times 2.5. How much sodium bromate can a 0 degree solution hold? Oh, that's right, no calculators. 60.5 grams sodium bromate. So is that the question that was being asked? Are we still not to the question? Honestly, who writes this stuff?
I
Rest-
gave you an invitation.
Okay, this still doesn't answer our question.
You subtract the 60.
You do. Because you've got this much stuff dissolved in there, but at 0, the solution can only hold that much. So what's going to precipitate out is going to be the difference between what's dissolved in there and what the solution is capable of dissolving. So we're just going to take the 93.72 grams NaPro and subtract the 60.5 grams of NaPro. I think that's just so funny. I don't know why. Okay. What do you get?
33.22 grams of sodium bromate.
Yeah. You're going to get 33.22 grams of sodium bromate precipitating out. Okay? So that's what you're going to expect to see sort of fall out of that solution. And it's like magic. It just like starts to appear, little snakes. Okay, 4 minutes and I'll see you then. So what you've got here is a worksheet with practice. This actually, I'll be honest, this, I guess I didn't wait long enough. This was an old quiz and I added one question type. So it's got all the 4 question types that I could potentially ask you. Usually for a practice I'd have more than one of each.
Teacher.
Okay, that's it. You've got some practice to do and you will have a 5th quiz tomorrow.